In this video, you will learn how to process data with pandas. So pandas is a package in Python very much used for pre-processing data. How can we read data from CSV files? So in order to use pandas, the first thing is import pandas. Import pandas as PD. This is very commonly used. And then use the read CSV method and give it the path to the CSV file. Data is read into a variable, and in this example it is uses df. Df stands for data frame, and then you can use the head method to extract a few records, usually 5 records by default, but you can also extract more than 5 or less than 5. Just give the parameter that you wanna tell the method. Like head 10 pull would extract 10 records, etc. The example later on that you can see in the Jupyter notebook reads data from 2 CSV files. So there's another called user device.csv, and eventually there are 2 data frames, uses df and device df, and there is a number of pandas commands to read data from other files, other type files, such as read excel, read starter, read sas, and read hdf. So as said before, in order to extract a few records, and usually 5 records, just use the head method. If you want to check the data type of the columns within the data frame, use dtype method. Dtype attribute. So use the dtype attribute after the name of the data frame and also the name of the column that you want to check the type. You can also check the type for all the columns, and in that case you don't specify the column names. Just write the name of the data frame and dot dtypes. There are many other attributes, such as columns, which lists the column names, axis, which lists the row labels and column names, and dim, which gives number of dimensions, size, which gives the number of elements, shape, which returns a tuple representing the dimensionality, and values, which is the numpy representation of the data. And these are some more examples of how to use those attributes. Regarding methods, there are several common methods such as head and tail. Head gives um, a few records from the top, and tail gives a few records from the bottom. Describe generates the descriptive statistics. Max and mean returns max and mean values for all the numeric columns. Mean and median return the mean and median values for all the numeric columns. SAD returns the standard deviation. Sample returns a random sample of the data frame. And drop all the records with missing values. So those are all the very useful methods that you can use with data frames. How do you select a column? There are usually two ways. The first method is very much commonly used more than the other, which is using the name of the column in the quote. And the second method is to use a column name as attribute. So you write the name of the data frame and then the dot and then the name of the column. So in this case, you specify the column, namely device. Group by. Group by is very much commonly used method for pandas data frames. Basically, it splits data into groups based on some criteria and calculate statistics for each group, such as like mean, min, max, sum, and etc. So this is an example. We have the data frame, namely device df. So call the method for the method group by for that data frame. Group by what? Group by what? Give it a list that has the label or the column name. You can group by more than one column. So if you have another column, just put uh, uh, the second or the third column in the list. Okay, and then you have the new data frame, df type. You can call the max method on df type. This gives you a number of columns, and you can specify the columns that you want to return. In this case, I use just one column. I give it just one column, platform version. So then this is the resulting data frame. There is one column, platform version. Next, we talk about filtering. Filtering is used to subset data from the original dataset. So let's say the original dataset is device df, a device data frame, and you want to filter rows that have platform is equals to iOS, right? So bring that condition here. Device df with the column platform is equal to iOS in a string, um, and store the result in a new data frame iOS data, and then take um, five rows, five top rows from the data frame. Another example is this is second example allows you to search for a string in the column device. So the condition is find rows that have the device, the column device um, containing the string iPhone. And this is a list of other Boolean operators such as greater, and greater than, less than, equal to, greater or equals to, greater than or equal to, less than or equal to, and not equal to. Let's talk about slicing. Slicing is to subset a data frame. You can subset one or more columns, right? That's column wise. Uh, one or more rows or a subset of rows and columns. Rows and columns can be selected by the positions or labels. Now let's see how we can slice data frames. You can use a single set of brackets like this. But the resulting object will be a series and not a data frame. So be careful with this. Use double brackets to select a column or more than a column. Then the result is a data frame. And if you want to store the result back in a data frame such as like df, you can do it this way. To select a range of rows, use a semicolon. Device df with a range from 10 to 110. This gives rows from 100 to 109 and not 110. Um, The next is selecting rows with row position and column labels. So when you select a data frame by rows with row positions and column labels, use the log method. So in the example, first you write the data frame name, and then the log method, you specify the range of rows that you like to select, and a list which has the labels, the column labels that you like to slice. In this case, platform and device. So in the result, you see uh, just the two columns. And if you want to select rows with both row positions and column positions, use the ilog method. In this example, the ilog method selects rows from 100 to 110 and the second and the fourth columns, which actually give you the same thing as we saw in the previous slide. If you need to select the last row or the last column, use -1. For example, if you want to select the last column, just say -1 and put it in a list so you can make sure the result returned is a data frame and not a series. And same here. If you like to get the last row, use -1 at the row position. Now talk about sorting with data frames. Basically, starting with the name of the data frame and then call the method, namely sort values. Sort value by what, right? By, and then give it the name of the column that you'd like to sort by. You can sort by more than one column. In this case, I have one column, namely platform, and I just need to extract 5 rows to see how data looks like. This second example shows you how to sort by more than one columns. Um, in this case, you just need to put more columns in the by argument. You can also adjust how data is sorted, ascending and descending. So here we have false and false, meaning both columns are sorted by the descending order. There are many uh, methods that you can use to deal with missing data. You want to simply drop missing rows, missing observations, say drop NA, call the drop NA method. Drop NA and the how argument um, with the all value. This um, only drop observations if all the cells is NA. There are some other examples like drop NA um, with axis 1 and how is all drop NA with some um, thresholding. Fill NA 0. This method replaces missing values with zeros. Is null method returns true if the value is missing, and not null returns true for non-missing values. We talk a little bit about aggregation functions. There are common aggregation functions such as min, max, count, sum, plot, mean, median, mode, and math. STD for standard deviation, and var for variance. And you can get multiple statistics using the AGG for aggregation. So if we apply that, we call that method AGG with count and max, right, for the two type of statistics, or device df, and this is what we have. So this is what we have. We have the two selected columns and the two statistics that were given to the AGG method. Now we talk about several methods for concatenating, merging, and joining data sets, data frames within pandas. Merge is used to combine two or more data frames, and joins is also used to merge two data frames using some indexes. And concat for concatenation is used to append one or more data frames on top of the others, or sideways, depending on the option for axis. So if the axis is 0, then the data frames would be put on top of each other. And if it is 1, then they would be on the side of each other. Join types. Join types very important. Join types. Usually, inner inner join is used very much commonly. There's others as well, such as left, right, and outer. The left join um, use calling frames index, meaning here uh, the result would return all the rows from the left data frame. With right join, it returns all the rows from the right data frame. And outer join return uh, all the rows on the left and the right. Doesn't matter if um, they are matched or not. And inner join, which is very much commonly used, only return the matches on both sides. Now let's see how it works. So previously we have two data frames. Device DF, which is very much about devices, and uses DF, which is very much about the uses of the devices. The common field or the common column is use ID. In order to merge the two data frame, you select um, the data frame to start from. Here I will start from device df and call the merge method. The first parameter is the data frame that you want to merge with, and merge on what? Okay, merge on the common um, column, which is use ID. And the last argument, which is how. Here you say you want to do inner join, so it returns only the matches. Here I only show 5 top rows from the result. In addition to merge, you can also use join to get the same result. Um, so looking at how it works, you start from the name of the data frame and call the join method. Give it the name of the data frame that you want to join with, but also you have to set index on that data set, so that the join method would know which column is indexed. The index is use ID. The index is the column that is you use to join with the device df data frame. Join on use ID and also use inner join. The result is the same. So there are two ways. Either you can use merge or join. With the same syntax, we change from inner to left, you change from inner join to left join. So this is the left join. The left join um, give you all the rows on the left, which is device df. So it lists all the um, device, even ones that do not have any uses. So you see NAN, all the NAN. These rows do not have matches um, on the uses. Similarly, if you change from left to right, then this is a right join. In the right join, you can see all the rows on the right data set are listed. Okay. All the rows from the data set on the right are listed, even there is no match on the left. You see here all the NAN on the left, but still list rows on the right. And finally, you can do outer join. Outer join is a combination of left and right. So uh, in the result, you can see rows that don't have, or devices that don't have matches uh, for uses, and rows that have uses but do not have matches on um, the device side.